Welcome back to our fourth and final video, lesson 4, unit 4, lesson 4.4, page 140. Again, dealing with inequalities, we're going to apply what we learned to solve two-step inequalities, and of course we're going to graph them when we're done. Now, hello, let's make this clear. Solving a two-step inequality is done exactly the same way as solving a two-step equation, except instead of keeping the equation balanced, we're going to keep the inequality true. And we have to pay attention and recognize and notice that one special case 2 times when we multiply or divide by a negative that will cause the inequality to be reversed. In every other case, the inequality stays true. We're putting all of it together to work it right now, solving these two-step equations. There's not a whole lot of notes to be taken, but there is something I want you to write down. There's not a lot of space, but I know you can squeeze it in there. So, right underneath where it says A, solving two-step inequalities, and right above where it says solve the inequality, graph the solution, I want you to write 1. Isolate the variable. Okay, we're going to isolate the variable. And then number 2, keep inequality true. That's what we're doing. That's what we're doing. So, ladies and gentlemen, you have that written down. Again, you might want to watch or look, learn, listen, all that kind of good stuff, and then pause to then pick up your pen, write it all down before moving on to the next example. So in example number 1, 3m minus 7 is less than or equal to 2. No pun intended there. So the first thing we want to do to isolate that variable is do the inverse operation to eliminate the constant. We want to combine these like terms by moving that constant -7 to the other side. The inverse is to add. And we're going to keep the inequality true by adding to both sides. And we don't have any bells and whistles because we're not multiplying or dividing by a negative. So 3m, when we add a number to both sides, the inequality remains true, less than or equal to. And of course, 2 and 7 is 9. And then we are going to divide by 3. And of course, case 1 says anytime you multiply or divide each side of an inequality by a positive number, the inequality remains true. So m is less than or equal to 3. Now we're going to graph. Our target number is 3. Our number greater 4, less is 2. We need a closed circle to indicate that our target number is included. Since the variable is on the left, we can graph, and you put our arrow to the left, indicating that all those numbers to the left of 3 are in the solution set. Let's move on to example number 2. Negative 13 greater than negative 5r plus 2. So let's start right off by combining these like terms. They are on opposite sides of the inequality, so our inverse operation is to subtract 2 from both sides. So we would have negative 15. What happens to the inequality when we subtract? That's right, nothing. It remains true when you subtract the same number from both sides. So is greater than negative 5r. So now we have to divide by that negative 5 to isolate the variable and leave us with r. And now, ding, 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 we are dividing by a negative, so we need to reverse that inequality symbol, and then we come over and divide negative 15 by negative 5, and again get a positive 3. Okay? And we get this positive 3. We have to, well, we don't have to. I prefer to. Can you graph it? Can you leave it just like this? You certainly can. But you know me, I don't like to. I'm going to rewrite and say r is greater than 3. So I come over here once again, 3, 4, and 2. And this time it's an open circle because our solution is, our target number is not included in the solution. And of course, the inequality symbol is now pointing to the right, so we can graph to the right when our variable is on the left. So again, a lot of things to be thinking about. We got to know them, and you got to pay attention. That's why you might want to look, listen, and learn first, and then pick up your your pen and write down your notes with quality. Ladies and gentlemen, let's move on to number 3. Number 3 says 2d plus 1/3 is less than 1. So the first thing we're going to do here is we're going to subtract 1/3. We're going to combine like terms right here, moving it to the other side of the inequality. That would leave us with 2d. And of course, 1 minus 1/3 would be 2/3. And again, the inequality remains true anytime you add or subtract the number to each side. That's what property of inequality for subtraction says. And now we're going to divide by 2 both sides. And we get d is less than, and we're going to get, well, we end up getting 2/6, but we know what that is. So d is less than 1/3 is our final answer. And of course, the inequality did not switch. Why did it not switch? We did not switch it. Why? Because we divided by a positive number. So our target number is 1/3. The next one bigger is 2/3. 0 is less than that. Our inequality symbol says that the target number is not included, the variable being on the left, and the inequality symbol says to graph to the left. Outstanding. D is less than 1/3. Moving on to example 4. 4.3 minus 1.5c is greater than or equal to 10. Okay? Greater than or equal to 10. So the first thing I'm going to combine like terms by moving that 4.3 over. So I'm going to subtract it since it's positive on this side. 4.3. And I get negative 1.5c is greater than or equal to, what is that, 5.7. Outstanding. And of course, the inequality symbol does not change when you subtract from both sides. And so now we're left with dividing by a negative 1.5. And of course, we do it to both sides. Over here leaves us c. But now we say ding, 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 woo, woo. We reverse that inequality symbol because we are dividing by a negative. And 5.7 divided by a negative 1.5 is negative 3.8 as our final answer. Our target number, negative 3.8. So 1 greater than that is negative 3.7. And less than that is negative 3.9. And our target number is included, so we use a closed circle. And with our inequality being, or excuse me, with our variable being on the left of our inequality, and the graph would go to the left because the inequality symbol points to the left, indicating that all those answers are in the solution set. Boy, I say the same things multiple times. I hope we're getting it down. Alrighty, let's go to our next example, number 5. 2 minus x divided by 3 is greater than 6. So the first thing I'm going to do is combine this 2 with that 6 on opposite sides. The 2 is positive, so I'm going to subtract 2 again, leaving me with negative x divided by 3 is greater than 4. Nothing happens to that inequality when we use the property of inequality for subtraction. And now we recognize that I have to multiply both sides by a negative 3. Right here, leaving with x, we hear bells and whistles, ding, ding, ding. I'm multiplying by a negative. That inequality symbol does need to be reversed. And then we multiply that 4 by the negative 3, and we get negative 12. Our target number, negative 12. Negative 11 is greater. Negative 13 is less. Our inequality symbol says that our target number is not included, so we use an open circle. Our variable is on the left of the inequality, so we can follow the inequality symbol and, again, graph to the left, indicating all numbers in the solution set. Ladies and gentlemen, that pretty much concludes our first video tonight. We only have 2, so we're going to get this one done with our quick write. You have 2 to solve and graph that we can review tomorrow as we revisit our notes. Go ahead and pause the video, write those down, then take a quick break, come back and join us for video number 2.